Welcome, everyone, to the deep dive from the A of Think channel. Great to have you with us. Have you ever really stopped to think about what's truly powering the intelligence behind AI? We hear so much about these incredibly complex algorithms, right? But is that the whole story? Or is maybe something more fundamental driving its capabilities?
That's a really great question to start with. And honestly, the answer often lies in something we deal with every single day, but maybe don't think about in this context. It's data.
Data. Okay. So data analysis. But we're not just talking about, hoarding piles of information, are we? It's more about pulling out real insights, actual knowledge. That's why they call this the information age, I guess.
Exactly. It's about the analysis, the
Yep.
transformation. Clive Humbleby, a British mathematician, made this fantastic analogy back in 2006. He said data is like the new oil.
Data is oil. Okay, unpack that a bit.
Well, think about it. Crude oil, straight out of the ground, isn't that useful, is it? You have to refine it. Data's the same. Raw data needs to be processed, analyzed, refined to unlock its actual value.
Refining data. I like
Well,
that. So how does this refining look when it comes to AI? Can you give us an example?
sure. Think about a simple photo, maybe one you took of your kittens. Cute, right?
Oh, nice.
For an AI, though, through analysis, that photo becomes learning material, the pixels, the arrangements it learns from that. It starts to figure out abstract things like catness, or maybe even what humans consider cute by looking at thousands, millions of cat photos.
Wow, okay. From just pixels to understanding cuteness, that's quite a leap. And what about on a massive scale, like Google? How are they refining data?
Well, Google's web spiders are constantly crawling, grabbing text, images, everything. That's the crude oil. Then their AI algorithms learn from this enormous pool of data. They learn language, context, relevance, incredibly complex stuff, really.
And we see the results, right? Like with Google's RankBrain.
Precisely. RankBrain is a perfect example. It learns from all that search data to understand those weird, ambiguous questions we sometimes ask Google.
The ones that aren't just simple keywords.
Exactly. It's already handling, what, something like 15% of searches? And because it learns from data, it just keeps getting better. Potentially, it could handle way more. The data fuels its intelligence.
It really does sound like data gives us new superpowers, almost, moving beyond how science used to work. Didn't Chris Anderson from Wired talk about this? How massive data sets let us find things without even knowing what we're looking for beforehand?
You got it. Chris Anderson pointed that out. Traditionally, science was hypothesis first, then data collection. Now, with these huge data sets, the algorithms can just sift through and find patterns, correlations, insights we might never have even thought to look for. Discovery straight from the data.
So it's not just that data helps AI, it sounds like it's more fundamental than that.
It's absolutely fundamental. Data doesn't just support AI, it enables it. Its intelligence, its ability to learn and improve, it's all tied directly to the data it gets.
That clicks. I remember reading something by Dr. Alexander Wisner-Gross. He argued that AI development wasn't always held back by the algorithms, but more by the lack of good quality data, or just not enough of it.
Yes, exactly. And what's really interesting is his point that many core AI algorithms we use today, they're actually quite old. Some are decades old.
Really, from like the 70s or 80s?
Some of them, yeah. But the data they run on is constantly new, constantly updated. So it's the fresh, relevant data that's really driving the progress we're seeing now. The algorithms provide the method, but the data provides the evolving smarts.
Okay, so if data is the fuel,
Mm.
what's the engine? How does AI actually use this data to learn? It's not like standard coding where you write add 2 + 2 = 3, right?
Right, you've nailed the key difference there. That's where machine learning comes in. Traditional programming, you give a computer the inputs and the rule of the function. Add 2 is the input, equals 3 is the rule. Machine learning flips it. You give it the inputs and you give it the desired outputs, and the machine learning algorithm figures out the rule, the function itself.
Ah, so it works backward from the examples to learn the underlying pattern. Kind of like how a kid learns.
That's a great analogy. Think about teaching a child what a tree is. You don't give them a mathematical definition. You just show them lots of trees, different shapes, sizes, leaves, and eventually they figure out the abstract concept of tree. Machine learning algorithms do something similar. They use these internal knobs and dials, technically called parameters like weights and biases, to map the examples to the outcomes. They build their own understanding.
But we humans are still involved. Yeah, we don't just dump data on it and walk away.
Oh, absolutely not. Human input is critical. We choose the right type of algorithm. We set up the initial learning conditions. Those are called hyperparameters. We select the right examples, the training data. And we often help identify the important features or characteristics in that data for the AI to focus on. It's like guiding the child, providing the right environment to learn effectively.
And this machine learning process, it's behind so many things now, isn't it? Things that work so well, we barely notice them.
That's so true. Their effectiveness makes them almost invisible sometimes. Think about fraud detection on your credit card.
Okay.
That little alert you get about a weird charge,
Yeah.
that's machine learning. It's learned your spending patterns and spotted something unusual. It's like a quiet little guardian.
Analyzing location, time, purchase type, all compared to my history. Wow.
Hundreds of factors,
Mm.
constantly. It's not just one thing. Or consider hospitals using AI for scheduling, getting the right patient to the right specialist at the right time based on needs, availability. It's complex.
That makes a huge difference.
Definitely. And doctors using it to help with diagnoses, looking at tons of symptoms and factors, automation systems using it to handle unexpected hiccups, avoiding shutdowns, even those automated voices when you call customer service. Often AI-powered now.
It's truly incredible how AI, especially through machine learning, is quietly transforming so many parts of our lives, making things smarter, more efficient. And hey, if you find this stuff fascinating, how these technologies are changing things, definitely check out more on the AI of Think channel. We love getting into the real-world impacts.
And there's more, like access control systems. Instead of just yes, no, ML can analyze if this specific employee should have access right now based on location, time, normal behavior, much smarter security.
Right.
Or even estimating wait times accurately. Restaurants, ride-sharing apps. ML analyzes staffing, current demand, traffic, whatever's relevant to give you a pretty good prediction.
Okay, it's clearly powerful stuff, but it's not magic. What are the limits? Where does it fall short? I mean, we've seen some public stumbles.
That's super important to talk about. A major concern is bias.
Yeah.
AI learns whatever we teach it. So if the data we feed it is biased racially, gender-wise, whatever the AI will learn and perpetuate that bias. The classic stark example is Microsoft's Tay chatbot. Remember that?
Vaguely, yeah. The Twitter bot.
Exactly. It was designed to learn from interacting with people on Twitter. Within hours, it was spewing racist, sexist, horrible stuff. It just learned from the toxic parts of the data it was exposed to. Garbage in, garbage out, quite literally.
That's a sobering reminder. So, biased data leads to biased AI. What else can't it do? It's not going to suddenly write the next great novel on its own, is it?
Well, not without significant human guidance and framing. Genuine creativity, imagination, that's a big limitation. AI is fantastic at remixing, combining, finding patterns in what it's seen, but creating something truly new, something outside its training data. Developing new concepts, not really its strength. It can't really think outside the box.
So pattern matching extraordinaire, but not an innovator in the human sense. What about things like intuition, gut feelings, empathy?
Nope, none of that. AI runs on logic, mathematics, statistics. It doesn't have intuition or make leaps of faith. And it definitely doesn't feel empathy. It can be programmed to recognize signs of human emotion, maybe, but it can't genuinely understand or share feelings like happiness or sadness. It's a process, not a conscious being.
And then there's that issue, overfitting.
Yeah.
Is that like it studies too hard for one specific test but can't handle slightly different questions?
That's a perfect way to put it. Overfitting is exactly that. The algorithm basically memorizes the training data, including all its quirks and noise. It gets really good at that specific data, but then it fails miserably when it sees new, slightly different data because it didn't learn the underlying general principles. It just memorized the answers for the test, like you said.
Okay, so understanding these limitations is key. You mentioned different types of machine learning earlier. Does breaking it down help understand how it works?
Absolutely. It helps clarify the different ways AI learns. Broadly, there are three main flavors of machine learning.
Okay, let's hear them. What's the first one?
First up is supervised learning. Think of it like learning with a teacher or supervision. The key here is that the algorithm learns from labeled examples. We give it an input and we give it the correct output, like showing a kid a picture of a cat and saying cat.
Input picture, output let label cat.
Exactly. The AI's job is to figure out the mapping, the function that connects the input to the correct output based on lots of these labeled pairs.
So predicting house prices from features and past sale prices would be supervised. Or identifying spam email.
Perfect examples. Predicting continuous values like prices is called regression. Predicting categories like spam or not spam or cat or dog, that's classification. Both are core supervised learning tasks.
Got it. Learning from labeled answers. But what if you don't have labels? Just a huge pile of raw data.
Great question. That's where the second flavor comes in. Unsupervised learning. Here, the algorithm gets unlabeled data, no answers provided. Its task is to find hidden structure, patterns, or relationships within the data all on its own.
So it's finding the patterns itself, like grouping similar things together without being told what the groups should be.
Precisely. Imagine looking at a huge collection of news articles and having the AI automatically group them by topic without you predefining the topics. That's clustering, a common unsupervised task. It's also used for things like finding customer segments in marketing data or simplifying complex data by reducing its dimensions.
Okay, that's pretty cool. Finding structure in the chaos. And the third type.
The third one is reinforcement learning. This is more about learning through trial and error, like learning from experience. The AI, often called an agent, takes actions in an environment. For each action, it gets feedback, maybe a reward for a good action, or a penalty for a bad one.
Ah, like training a dog with treats. Or maybe like learning to play a video game.
Exactly like learning a game. Get points for good moves, lose points for bad ones. The AI's goal is to figure out the strategy, the sequence of actions that maximizes its total reward over time.
And that's how things like AlphaGo learn to play Go, by playing itself millions of times and learning from wins and losses.
That's a prime example. AlphaGo Zero learned entirely through reinforcement learning, playing against itself. It's also huge in robotics, teaching robots to walk, navigate, manipulate objects by rewarding successful actions.
Wow. Supervised, unsupervised reinforcement, 3 different ways AI learns from data. This whole deep dive really shows that AI, while amazing, isn't some kind of magic. It's built brick by brick on data, carefully analyzed using these different learning strategies.
Right, and knowing that helps us appreciate both what it can do, its incredible potential, but also what it can't do, its limitations. It forces us to be more critical, more thoughtful about how we build and use it, and it really brings up a big question for the future, doesn't it? How will our understanding of AI being so data-dependent shape how we handle things like ethics, fairness, and decide where we apply this powerful technology?
That is a fascinating thought to leave folks with. How do we steer this data-driven intelligence responsibly? Well, we hope this discussion gave you a much clearer picture of data analysis, the real engine behind AI smarts. Don't forget to subscribe to the AI of Think channel for more discussions like this one. And hey, if you found this interesting, share it with someone else who's curious about artificial intelligence. Thanks for tuning in.